Professor Bialis here. In this video, we're going to talk about section 3.3, which is covering intercepts. Now, when we cover intercepts, we're going to be talking about, first of all, what they are, how to recognize them, and then how to use them to graph a line. Okay, so first of all, what are they? Let's define them. There are two types. There are X-intercepts, and then there are Y-intercepts. Now, X-intercepts are going to be the point or points where the graph crosses or touches the x-axis, hence the name X-intercept. Y-intercepts, same exact thing, but for the y-axis. So it's the point or points where the graph crosses or touches the y-axis. Okay, now I want to be very clear on something. These are points. Okay, there are a lot of times where people just look at these as numbers, but they are in fact points. So when you are writing an intercept, write it as a point. Now what do I mean by that? Let me ask you this. Let's say we have a line that looks like this. And I ask you to identify the intercepts. I am looking for the X-intercepts and the Y-intercepts. In this case, there is going to be one of each. The X-intercept, if you look, is at 1, 2, 3, 4, comma 0. Don't just say the X-intercept is 4. Okay? The point 4, comma 0 is your X-intercept. Okay? After that, let's go to the Y-intercept. We go up 2 units. Is the Y-intercept 2? No. It's 0, 2. Make sure you write it as an ordered pair. Okay? How about this graph? Let's say we have something like this. Okay? Now, don't worry about actually graphing that. You will talk about that in a later course. All I want you to be able to do is look at that and say, where are the intercepts? Okay? So, there's going to be a crossing here, a crossing here, crossing here, and a crossing here. So, as we can see, there's 3 X-intercepts and 1 Y-intercept to this graph. Okay? The X-intercepts are going to be -2, 1, and then 2, 3, 4, 5, and 6. -2, 1, and 6. But I'm not just going to write -2, 1, and 6. I'm going to write -2, 0, 1, 0, and 6, 0. Okay, you should start seeing a consistency there. And then the Y-intercept is going to go up 3 units, so that is 0, comma 3. Okay? Now, what is the consistency? Whenever I have an X-intercept, for a point to be on the X-axis, you have to have an X-coordinate, but a 0 for the Y-coordinate. Okay? Same thing with the Y-intercept, except 0 for the X, and then some unknown number for the Y. That will never change. I don't care if you get a PhD in mathematics, this will never ever change. Okay? And whether we're graphing lines or curves like this or something even more complicated, that is never going to be different. So we will always be able to fall back on that idea and on this model for the ordered pairs. Okay, so we know what intercepts are. We know how to identify them off of a graph. Now let's use them in order to graph. Okay, so let's clear up the board here. So the instruction is going to be graph using intercepts. Okay, always pay attention to the instructions, and if they say do a task using a given method. Okay, in the previous section it was graph using a table of values. That's where we pick 3 random values, plot those points, connect the dots. Here we specifically want to find the intercepts. So let's look at an example. Let's say we have this. Okay. Now, if we were doing a table of values, that's when I said solve for y, because you only have to solve it once then. When we're graphing with intercepts, we're not just going to find the y every single time. So honestly, I would leave the equation as is. Okay, when you're looking for intercepts, just leave it as is. Now, if we're looking for intercepts, that means we are looking for an x-intercept and a y-intercept. Now, think back to a couple minutes ago. What do we know about every x-intercept? Every x-intercept has to have a y-coordinate that is 0. What's true about every y-intercept? Well, y-intercept, the x-coordinate has to be 0. So what we're doing is locking in the y-coordinate here, the x-coordinate here, and we're looking to solve for the corresponding other coordinate. Okay, so if we know y is equal to 0, let's plug and chug. Just like we were doing with a table, except here we're specifically looking for the intercepts. But that's really all this is a table of values, but with specific values instead of just a randomly generated list of numbers. Here then, we've got the 2x equals 4, and then we can divide by 2. And then we've got 2 comma 0. Okay, that's 1 point, specifically the x-intercept. Let's go to the next one. 2 times 0 minus y equals 4. 2 times 0 is 0, so negative y equals 4. I divide by a negative 1, and y is negative 4. Therefore giving me the point 0, negative 4. I just found 2 points. Specific points, but still 2 points. Remember, how many points determine a line? 2. This gives me enough information to graph. However, when we did the table of values, I always asked you to find 3. That third point was simply there to check. I asked that you do the same thing here, because then that will verify that you're on the right track with the 2 points, 2 intercept points that you have. Now when we find that third point is just a random point along the line. So I am going to go back and say let x equals. You can put something in for y if you want, but just to keep it consistent, let's stick with the x. Okay, I'm going to let x equal whatever I want, just not 2 and not 0, because I already have those. Let's go out to maybe 4. Okay, try to space it out a little bit, because if you keep them all close together, even if they're off, you may not see it. Okay, so if x equals 4, I've got 2 times 4 minus y equals 4. And then I just go ahead and solve that. So I have 8 minus y equals 4. Subtract the 8. Don't lose the negative on the y. And then I can divide by a negative 1. So I get the point 4 comma 4. And now I have 3 points, 2 of which are intercepts. So if I plot those, I've got 2, 0. I've got 0, negative 4. And then 4, 4. and those make a nice straight line. Just to verify, use that straight edge, connect the dots. And we're good to go. Okay, so again, this is very, very similar to using a table of values. It's just here we are going to be finding specific values with those intercepts. Okay, let's look at another example. Let's say we have that, okay? So, we're looking for intercepts, so we need an x-intercept, a y-intercept, and again, what do we always know? Y is 0, x is 0. Again, this layout is not going to change, okay? So, even if you're taking Calc 3, this will still be applicable to those graphs in those situations. Okay, so when we plug these in, we are going to get 0 equals 3x. Now watch how this comes out. I'm going to divide by 3, and I got x equals 0, which gives me the point 0, comma 0. Now, what is 0, 0? 0, 0 is the origin. Okay, that's a pretty important point. Let's see what happens with the next one. Y-intercept, x equals 0. So y equals 3 times 0, or y equals 0. So, what did we just find? We found the origin in both cases. Now, does that make sense? In this case, yeah. Because when I'm at the origin, what axis am I on? I'm on the x-axis and the y-axis, so I'm on both of those at the same time. So, if you get an x-intercept that's the origin, your y-intercept better be the origin as well, or at least one of the y-intercepts better be the origin. Okay? In this case, you're just going to have one, but in the future, when you deal with more complex graphs, you may have, multiple. Okay? So, if you have 0, 0 here, you should expect 0, 0 here. If you have 0, 0 and then 0, 3, something's wrong. Okay? So we have the origin. Now, that's not a bad thing. However, we only have 1 point. Okay, how many points do we typically want to find? We typically want to find 3. So that means we still need to find 2 more random points along that line. Again, a second one is necessary. A third one is just to check. So I'm going to let x equal, let's say, 2, and let x equal -2. Okay? So if I plug that in, y equals 3 times 2, or y equals 6. So that gives me a 2, 6 as another point. And then over here, I've got y equals 3 times -2, or y equals -6. So that gives me -2, -6. Okay, and now I'm going to have the 3 points I was looking for. So I go 2, 6. And I go -2, -6. Connect those dots, and I'm good to go. So when you get the origin as an x-intercept to start, a couple things to remember. You should get the origin here, and then you'll still want to find 2 extra points at the end. Okay? I wouldn't say, oh, this is 0, 0, so that's automatically 0, 0. Okay? Because if you make a mistake here, you don't want to then carry that mistake throughout the problem. Okay? Use that as an expectation, okay, to check, but don't use that to do the problem. Whenever there's something that you know should happen, unless you are crunched for time, I would never use that to accomplish or carry out a problem. If I think something's going to happen or expect something to happen, use it as a check. Okay, therefore, when it does happen, we're on the right track. Okay, so there's your example. Again, 0, 0, 2 extra points. Let's look at another one. How about 3x equals negative 5y plus 10? Now again, when we're using intercepts, we're going to be plugging x in, we're going to be plugging y in, just leave the equation as is. You can solve it and rearrange it if you'd like. I really don't see the need for that. Okay, so I'm going to write down x-intercept, y equals 0, y-intercept, x equals 0. Okay? Plug those in and see what we get. We get 3x equals negative 5 times 0 plus 10. So that goes away when we multiply by 0. And then I'm going to divide by 3. And I get 10 over 3. But when we're plotting points, usually I say don't do mixed numbers. I would do a mixed number when I'm plotting points, simply because it's easier to wrap your brain around the mixed number versus the improper. Okay, so what I have is a 3 1/3, comma 0. That's a lot easier to think about and picture than 10/3. Okay, let's go to the other one. We've got 3 times 0 equals negative 5y plus 10. So this goes away. Now careful, that doesn't mean that this side's gone. It's just a 0. Okay? And now we solve from there. Subtract a 10. So we've got negative 10 equals negative 5y. Divide by negative 5. And we get a 2. So we've got this here, and now we have 0, 2. Those are your intercepts. Okay? Now if we're graphing with intercepts, a third point's a nice thing to have just so we can check to make sure we're on the right track. So I'm going to let x equal something else. Okay? Now I have a 3 1/3, I have a 0. Especially since there's that fraction that we're going to have to approximate on our graph, I would go as far away as I can. I wouldn't go too far because then I'm going to be off the graph. But you're at 0, you're at the 3 1/3. Let's go maybe negative 3, just to space it out. So I'm going to go with negative 3. Okay, you can plug in a fraction. I really wouldn't do that. I would just keep the integers. If a fraction comes out at the end, great. Just deal with it. But I wouldn't force a fraction into it in the beginning. So I've got 3 times negative 3 equals negative 5y plus 10. That's a negative 9. And then I subtract the 10. That's a negative 19 equals negative 5y. Divide by negative 5. So I got positive 19 over 5. Now again, I would convert that. So I have a negative 3, comma, 5 goes into 19 3 times with 4 left over. And we have that. Okay, now we're going to have to graph some fractions. Just do the best you can. Okay, so we've got 3 1/3, comma 0. So let's see how that looks. I go over 1, 2, 3, and a third. A third is not quite a half. So I'm going to go somewhere between that line and halfway in between. Okay, now I'm not going to be taking out a magnifying glass to make sure that it's exactly 1/3. Just make sure it's a reasonable approximation. Okay, if this was some engineering problem or design problem where I'm building a structure, then I would want a little bit more accuracy, obviously. But here we're just trying to get the general picture. Then we go to 0, 2. That one's nice and clean, 0, 2. And then we've got negative 3, and then 3 4/5. So I go up 1, 2, 3, and 4/5 is almost all the way to that next line. And now I can step back and see that those 3 points make a nice straight line. Verify that with our straight edge. And go from there. Now, it is common, if you have those fractions, when you put the straight edge there, to be off a little bit. Now, if it's off a little bit, you should be able to look at it and say, oh, I could have been a little closer to a certain line or approximate a little bit better. But if it's way off, then you graphed it wrong. Okay, so it may be slightly off, but not way off. If it's way off, then you got to look at it again, and maybe your number's wrong, or maybe you graphed it wrong. Okay, so let's now go into a couple special cases to finish this off. Let's say we have x equals -2. Okay? Now, at this point in the game, if you look at that and you remember from the previous section that x equals -2 is a vertical line, and you want to jump right into that graph, great. I am totally okay with that. That to me shows you know what you're talking about. Okay? So if x equals -2, I'm going to go on the x-axis to a -2, and I'm going to draw a vertical line. Simple as that. Nothing more to it. However, what if they specifically ask, what are the intercepts? Okay, and you wanted to kind of, maneuver your way through that process. Or let's say you're looking at that and say, oh, is that vertical or horizontal? I forget. Don't just guess. Dig in a little bit. So this is how it would look if you have to dig in a little bit. I'm still going to go with x-intercepts, y equals 0, and y-intercept, x equals 0. Okay? Now, y equals 0. There's nowhere to plug that y because y has nothing to do with it. If the y is 0, great. I don't care. X is still -2. Okay? So what I get is -2, 0, which I can verify for my graph. Now what about that y-intercept? Okay? The y-intercept says x would have to be 0. For it to be a y-intercept, the x has to be 0. But the equation says x has to be -2. That means that 0 can never happen. So there's nothing to plug in, there's nothing to find. Y-intercept? There is none. And again, you can verify that from our graph. This will never cross that y-axis. Be very careful when the answer is none. Don't put a 0. It's none. 0 is a numerical value that can be applied to something. But if something just doesn't exist, we need to specify that accordingly. Okay? So let's look at the alternative to this. What if I gave you y equals 4? Okay? Again, let's say you really have these special lines down, and you look at that and say, I know that's horizontal, and I know I'm going on the y-axis up 4 units, and I'm drawing my horizontal line. Great. More power to you. That's awesome. Okay, but let's say you're looking at it and you're like, I don't know if that's vertical or horizontal. Or your instructor says, I need to see every bit of work here. This is what it looks like. Okay? X-intercept, y equals 0. I can't have that. The equation says y has to be 4. So if y has to be 0 for an intercept, there is no intercept. And again, verify that on the graph. This horizontal line is never going to cross this x-axis. So there is no x-intercept. For the y-intercept, the x has to be 0. Okay, that's fine. The y has to be 4. And I get 0, 4. And that's where I'm crossing the axis here. Okay, so again, these vertical and horizontal lines, me personally, I am totally okay with you just looking at it, graphing your line. done. That shows me that you really have these down, and that's an important thing to have down. But if you aren't sure, or if later they specifically ask you for intercepts and you don't want to graph it for whatever reason, then this is how you can think through it and get the intercepts very easily, very quickly, just by thinking through what goes where. Okay? So intercepts, we're looking for where we're coming in contact with the x and y axis. That's really what it comes down to. Just take your time with it. Know these setups right here. Those are not going anywhere. Write them down automatically with every single one of these problems. Okay? So, as always, work hard. Let me know if you have any questions, and I'll see you next time.